Okay, a quick video here where we're going to talk about the classification of matter. I'm just going to work through how we classify it into 4 basic types of things and then give you a really brief idea of what the particles would look like in those individual things. So, we start with matter. And by matter I mean things that have mass and occupy space. Those types of things can be broken into 2 basic categories. Pure substances Pure substances are substances that have all the same, that's not the best way to put it, I'll try that again. Just one type of particle. That particle might be comprised of different atoms, but every one of those individual particles is the exact same. Alternatively, we have mixtures. These are different substances mixed together. And then we further divide our pure substances into 2 basic ideas. We have elements These guys have one type of atom. Or compounds. The definition for compound is a little bit tricky, but there's a reason it's defined the way that it is. It says that the atoms combine in a fixed ratio. This is a not ration ratio. Try that again. There you go. Okay. What does that mean? Well, we have 2 basic kinds of compounds. This isn't it, but it gets to the idea. We have things that form molecules like H2O. And what we see here is in these things we have 2 hydrogens for every 1 oxygen, and this flies around as its own little particle. Or we have things like salts, like NaCl, that form these large crystals. They don't fly around as individual little particles themselves, but instead exist as what we call an ionic crystal, where all of the ions in the crystal stay together and form one big clump. And often these clumps, when we look at them ourselves, look like these very beautiful crystals. What's important, or why we call this a compound, is because we can define a simplest unit of this ionic crystal, NaCl, and recognize that there's a fixed ratio between the 2 types of atoms that make it up. 1 sodium for every 1 chlorine for this example. It doesn't have to be 1-to-1, but it can be. So that's compounds. And why it says fixed ratio instead of saying molecule or something like that, because this is a molecule. But this is still a compound even though it's a crystal. Finally, for mixtures, actually before I go to mixtures, I just want to make a quick comment about elements. When we think about elements, we often think about things that we consider each atom its own individual things. But remember, it says 1 type of atom. It doesn't mean that those atoms can't be bonded to anything else. So something like a diatomic oxygen, where you have 2 oxygen atoms that are floating around together in 1 particle, is still an element because it only has 1 type of atom. So here we have examples of iron, oxygen, maybe helium gas like we might put in a balloon. Any piece of matter where it's only 1 type of element that's making up that matter. Matter in a fixed ratio. And then mixtures. Mixtures, we have 2 basic categories here. One we call solutions, or another term for this is homogeneous mixtures. These are ones that are mixed so well that you can't see that there are two different substances. Here I think of something like a glass of water sitting on a table. If I had come along and put a tiny amount of salt into that glass of water and stirred it really, really, really well, now it's water and it's salt. The two things are mixed together, making it a mixture. But it's a solution because if I handed you that glass of salt water, you wouldn't be able to tell that it was a solution because the particles, the salt particles and the water particles mix so well that we can't tell them apart. So here, if we imagine we have our water molecules, and then our salt particles go right all over the place inside of them. And they mix up so well, and atoms are so small that we can't see individual atoms. And so since they don't separate out into phases, when we look at this, all we see is the glass of water. We don't see the individual little particles, which are dispersed or that are separated throughout the entire mixture. Finally, mechanical mixtures or heterogeneous mixtures. Here, the types of substances clump into phases where we can clearly see the different types of materials. So for example, if we imagine some oil, which kind of looks like a long chain polymer, sitting on top of some water, so here's my oil, here's my water, and the two don't mix, and so it's clear that there's oil and water there just by looking at it. See the X's and the O's here, the different types of particles all mixed together so that you couldn't see any one thing. Here they separated into what we call phases. And these phases are groups of molecules that are all clumped together and as a result are clearly visibly different from each other. The phases don't have to separate out this well. We can imagine, for example, some sort of salt that isn't soluble in water but doesn't separate out that nicely, forming small groups of particles within the liquid, making the liquid look cloudy. And this would be something like muddy water, something like that, where you can clearly see the mud particles in the water. So clumps don't have to separate out. They can separate out into little clumps or small phases. Basically, the difference between these two things is if the phases get large enough that we can see them, then we call it a mechanical or heterogeneous mixture. So that's the most basic way that we classify matter. And we'll be looking at some specific examples of all of these things as we go through.